I just want to thank everyone for coming up here. It's a long ways, driving all the way up here. It's a long ways walking from the parking lot to here. So I'm going to tell you the story about this new planet that we think is in the solar system. But to tell the story about this new planet in the solar system, we really have to step back and think about the discovery of planets in our solar system. And I want to step back to 1780. If you go back to 1780 and you were up here on the mountaintop in 1780, first I'd wonder how you got here, but if you were up here and looking at the sky, you could see all of the planets, all of the known planets. If you knew where to look, you could see Mercury down low, maybe setting in the west. You could see Venus bright, Mars nice and red. You could see Jupiter, you could see Saturn, you could, well, that's it. Those are all the planets. So you could see them. And the planets were things that you could see and things that you knew where they were in the sky. I'm just going to keep talking until slides appear. And so it was an interesting moment. The very next year, I took you back to 1780. Now fast forward to 1781, and William Herschel is scanning the skies, trying to map out the shape of what we now know to be our galaxy, mapping it out by mapping where the stars were in the sky. So he would literally look through his telescope. It was the best telescope in the world at the time. He would look through his telescope. This is a bad idea. This is a laser pointer. Don't take it and point it in your eye like that. It's a telescope. Bad plan. He would look through the telescope and write down where the stars were, make a little chart of where the stars were. And with this new great telescope, the star images were super crisp. And he got to one star, and it was fuzzy. And, that's okay. There are fuzzy things in the sky. Even back then, they knew about them. They called them nebulae. But there are things like galaxies. They didn't know what galaxies were, but they were big fuzzy things in the sky. There are things that we now call planetary nebulae, fuzzy things in the sky. All those things you've seen pictures of are the nice. It was working really well right until we started here. And so he saw this fuzzy thing in the sky, and he thought, okay, it's probably just a nebula or something. Herschel, in 1781, was a very careful astronomer. And one of the things he did that really no one had been doing before is he went back and checked all of his positions the next night. And he would check, and the star was there, and that star was there, and that star was there, and the fuzzy thing was there. The fuzzy thing had moved. As soon as you see something move in the sky compared to the stars, you know it's not a star, it's not a galaxy, it's something in our solar system. And you could tell by how slowly it was moving that it had to be extraordinarily far away, extraordinarily far. In this case, interestingly, I would have just said all these same things anyway, and I wouldn't have changed slides yet. So this has all worked out fine. Thank you. So extraordinarily far was as further than Saturn, further than the most distant planet. And that was strange. It's interesting because, now we hear speculations about new planets and everybody talks about Planet X and everything else. In 1781, as far as I can tell by kind of going back and looking at old books and old news, nobody was thinking that there might be new planets to be found. So when Herschel found this fuzzy thing out beyond Saturn, he didn't really think it was a planet. He thought it was maybe a comet. People knew that comets sometimes went really far away, so he called it a comet. But so other people insisted that he had just discovered a new planet. It took him a couple months to be convinced, and finally he was like, yeah, this is a planet, and I'm going to call it George. This part is actually true. He wanted to name it after King George, which is a very smart thing to do when you want funding from your government. And do you know who hated the idea the most of calling it George? So you would think because we are, American-centric, you'd think it might be 1780, it might be the Americans. Who hated the British even more than the Americans in 1780? The French. So the French were like, no. It will not be George. And so it got to be called Uranus in sort of keeping with the tradition of the planets. The one thing that the reason why Herschel wasn't yet really convinced, and a lot of people were still not sure if it was a planet or not, is because they didn't know how it went around the sun. The planets that we knew about all go in nice circular orbits around the sun. comets start out far away, they go in close, they go further away. But this new object had only been found for a few months, so it was difficult to know what its orbit was. So this problem was solved in 1820 by another astronomer. See, here's my second slide. Another astronomer, Alexis Bouvard. Alexis Bouvard was the director of the Observatory de Paris, and he wrote this fabulously fascinating book called Astronomical Tables of Jupiter, Saturn, and Uranus. And it's full of tables of Jupiter and Saturn and Uranus and where they are in the sky night after night after night after night after night after night. But there's one page that I really like. I'm going to trip on this. Look at this. There's one page that I love the best, which is this page right here. There's a bunch of math. It's not even really that complicated math, but this math is how Bouvard predicted where Uranus should be based on gravitational perturbations of Jupiter and Saturn. So planets go around in elliptical orbits around the sun, but they're not perfect because the other planets move them around a little bit. And so Jupiter and Saturn are quite massive, so they move around Uranus a lot. And so Bouvard figured out where Uranus should be, and he has this great table that I'm going to zoom in on so you can really see this great thing. He has this great table of where Uranus should be compared to where it is. And the year, here's years, and the error in where it was. So here's the discovery, 1781, and the errors, you can see they're sometimes positive, sometimes negative, sometimes it's a little in front, a little behind. But the interesting thing about this one, 1781 was the discovery. There are observations all the way back to 1690, which is kind of amazing. These are people who were doing just what Herschel was doing, making charts of things in the sky. And Bouvard went back and found those charts and said, hey, you put a star there that's not there. And then, like, this might be Uranus. So he would say, that's Uranus, and he'd keep on calculating backwards. So all of these people could have discovered Uranus earlier if they had only looked a second night and seen it move. I mean, really, it's kind of amazing. But Herschel, 1781, did, and so he got to discover it. So it's interesting, you know, it's Uranus is a little in front, a little behind, a little in front, a little behind, behind, in front, and Bouvard is what we would call today the preeminent astrophysicist of his time. I know these people. We have people like that in my very own department at Caltech. I know them all around the world, and they're all exactly the same. And they were just like Bouvard. Bouvard said, my theory is perfect, and so the astronomers are terrible, and they need to make better measurements. So the astronomers are, oh, we feel bad. Bouvard said we're terrible. So they went back and tried to make better and better measurements starting in 1820, and it kept on being in the wrong place. Even with these better measurements, Uranus was discrepant. And Bouvard did have a little weasel out down here. Oops, it's down here on the page, where he said, well, it's possible maybe that there's something else out there pulling on Uranus that we haven't found yet. By about 1840, everybody understood this to be true. This is something that when you hear stories about the discovery of Neptune, which is what we're leading up to, people don't usually talk about the fact that everybody knew it was out there somewhere, everybody who was paying attention to astronomy in 1840. But it took until 1845 when Urbain Le Verrier, also at the Observatory in Paris, he used these exact data to calculate where this planet should be. He sent his predictions to the observatory in Berlin, and they opened up the telescope that night, and boom, there was a new planet that had never been seen before, which is what we now know as Neptune. This is, to me, one of the still most amazing stories of a discrepancy and then a prediction and then a discovery in the early days of physics. This is the day that I think people who were paying attention realized that this new physics thing was not just some cute thing that you could use to calculate, you know, an apple falling from the Leaning Tower of Pisa or whatever it was. but you could actually use it to discover things about the universe. It's an astounding discovery at the time, and rightly so. Leverrier got super famous. He was declared to be the astronomer who found a planet at the tip of his pencil. His name is inscribed in the Eiffel Tower. Only 50 people had that honor at the time. More people do now. Me too. You just scratch it there yourself. It's okay. But it was pretty good. He's got a statue at the Observatory in Paris, looking straight up towards Luxembourg Gardens, right down the central axis that goes right to the Louvre. I mean, pretty famous. So, as you might suspect, he got really famous from this, and other astronomers are like, I want to be famous. I'm gonna predict planets. So people started predicting planets left and right. We have tried to count all the predictions from then until now, and we've come up with something like 35. We might have missed some individual predictions of, hey, we think there's a planet because blah. And blah is usually that there's some discrepancy in the solar system that you see, gravitational, orbital, something, and a planet might be the reason. And the most famous of these that people know about was from an American astronomer. He was in Boston at the time, Percival Lowell. Percival Lowell, it's a crazy story that you should ask me about sometime, why he was trying to predict planets. But he was trying to predict planets, and he predicted planet P, didn't find it, Q, R, S, T, U, V, W, and his final prediction was actually planet X. Everybody thinks planet X is like 10 or unknown or something. It was really just the next letter in the alphabet from Lowell. And so he predicted this planet, and he thought it was there, and he thought it was there because he thought still Uranus and Neptune were not quite orbiting exactly right, and there must be something else going on there. He predicted where this planet X should be, and he sent a crew up to, I give this talk all the time in Pasadena, and I always point to where he sent the crew to. Now it's a little easier. He sent the crew to right here. He sent the crew to Mount Wilson. Before there were telescopes up here, it was still known to be a great place to do astronomy. He sent a crew up here to look for his planet at the predicted site. And they took a picture. It looked something like this. And do you guys see it? No. So he thought that this planet that he was looking for was going to be huge. And so it would have been, this big on this photograph. He didn't see it. He passed away before anything was ever found, and he was kind of disappointed. But he did found the Lowell Observatory in Flagstaff with the explicit goal that he wanted to go find this new planet. They built a special telescope just to find this new planet. They hired a kid off of a farm in Illinois, Clyde Tombaugh. Clyde Tombaugh went to Flagstaff, where the Lowell Observatory is, and he took a picture of the sky. They said, go find a planet. It's out here somewhere. And he took a picture of the sky that looked kind of like this. And he's like, how am I supposed to find a planet? But he's a smart guy, so he realized that the way you find a planet is to do what Herschel did. You take a picture of the sky, you come back the next day, you take another picture, and you saw it move. You guys saw it move, right? No, you didn't. Let's try again. Here's first night. Here's the second night. How many people think you saw it? No, you didn't. Let's try again. Here's the first night. Here's the second night. Anybody? Anybody? No, I don't believe you. Let's try. But everybody always gets it the fourth time. I don't know why. It's this something your brain, it sinks in. So let's try it the fourth time. Here it is. Here it is. Okay, who actually saw those pair and thought, yeah, okay. Easy to say that now. But, so these are literally Clyde Tombaugh's discovery images of Pluto that he took with his photographic plates, his special telescope, and it led to, of course, the big New York Times headline, 9th planet discovered at the edge of the solar system, first found in 84 years. 84 years ago was Neptune. Lies far beyond Neptune. So far, this is all true. Let's see where it gets untrue. 25-year search begun by late Percival Lowell. His search started right here at Mount Wilson. Observatory staff spots it through a special photo telescope. I don't know what that means. Makes thorough check. All true. The sphere possibly larger than Jupiter. I'm sorry, possibly larger than Jupiter and 4 billion miles away, meets predictions. 4 billion miles is right. Larger than Jupiter is wrong, and it's wrong by a factor of 250,000. So astronomers, we will give each other a factor of 10 here, a factor of 10 there, even a factor of 100 if we're friends. 250,000 is a lot, but the reason why this was wrong, the reason why it was declared to be a planet, is because of this thing, meets predictions. There was a prediction from Percival Lowell that there was a planet here. Clyde Tombaugh found something, and it must be this thing that was predicted. This is something that I think happens in science more frequently than you would know. If somebody has an idea of something, they find something, and they make the assumption that that's what it was that they were looking for. Science nicely corrects that when it's wrong, but sometimes it takes a little bit of time. Here it took a little bit of time. Let's go back and look at this again. There it is. It is possibly larger than Jupiter. It should have been like this big. It's so small I can never find it. I don't know, it's one of these things. I can always find it, I can find it in the second image because it's smeared a little bit, right? Isn't there a little smear? Is it that? No, I don't know, I'm not a very good astronomer. It was this tiny little thing, and people were really surprised at how small it was. And they had all kinds of crazy ideas, including some super crazy ones, like it's made out of uranium. This was 1930. They didn't yet realize that's a really, really bad idea. So the real answer, but the reason that they wanted it to be big is because it was supposed to be massive enough to be pulling Uranus and Neptune off their tracks. Turns out we now know that Uranus and Neptune are exactly where they're supposed to be. There's nothing pulling Uranus and Neptune off their tracks in any way we can see. So we have another explanation. Anybody know why Pluto looks so small? Because it is. But to put this in perspective that you often don't get, here are the planets. Here are the planets in their real size, not your lunchbox that my daughter had when she was in second grade size, but big. So Jupiter is huge. Here's the huge Jupiter. Saturn, even without its ring, very large. Uranus and Neptune, Mercury, Venus, Earth, Mars, and then even the asteroids show up here. And the biggest one is Ceres, right there. The Ceres is the only one that's bigger than 1 PowerPoint pixel, but there are about 10 that are a PowerPoint pixel, and then a million that are too small to even show up on there. Pluto, if you look very carefully, you might see it when I add it on there. There it is. It's kind of a little pathetic thing down in the corner, and but nobody really knew what to call it, so it was called a planet at the time. There's some other weird things about Pluto, and one of them that you probably know is if you look at the orbits of the planet, here's inner solar system, Jupiter, Saturn, Uranus, Neptune. If you put Pluto on there, Pluto dips inside the orbit of Neptune for part of its orbit, which is weird, and possibly even more weird, if you tilt the whole solar system on its side, you'll see that the planets are all in a nice thin disk going around the sun, and Pluto's tilted by about 20 degrees. It was strange. People didn't know what to make of it back in 1930, and just like, well, it's a weird planet, it's an oddball, we don't know what to say. But starting in 1992, another object was found beyond Neptune, and then another, and then another, and then another. And as of now, there are something like 4,000 objects known beyond Neptune, sometimes inside of Neptune's orbit, sometimes beyond. And these objects, if you put their orbits on there, they're like Pluto. They're tilted this direction, they're tilted that direction, and if you look at them from the top, you'll see that they are also on these eccentric orbits. Some of them dip inside of Neptune's orbit, some of them go much further out, but they really show you that Pluto, though it was an oddball when it was first discovered, really is part of this family in the solar system. This is the inherent reason why Pluto was demoted from being a planet. And I like to think demoting is not the right term. I would like to say really that in 1930, we mischaracterized it as a planet. It never was a planet. We never really changed our definition of planet. We just finally realized that Pluto never fit it to begin with. Okay, so the nice thing is, with 4,000 or 5,000 of these objects out there, we now have many more objects that we can look at to try to see if anything's being pulled along by something else out there. We know there's nothing really massive right outside Uranus and Neptune, but what if there's something more further away? So we examined all the objects. So if we go back about 25 years when these discoveries were first happening, we looked at all the objects. Everything was where it was supposed to be. All of these objects here with their weird orbits, you can explain just by their formation in the solar system in a way that we understand. Interacting with planets, they get kicked around, they do these things. The solar system all made sense. All of this was ruined by me in 2002 when we found this first new object that was weird. So let me show you this object, but first I have to show you its orbit. Its orbit is so big, it doesn't fit. We have to go in there all the way to here. The object is called Sedna. We found it in 2003, and it's on an orbit. It takes about 5,000 years to go around the sun. And the really weird thing about it is it never actually gets very close to Neptune at all. And that is not possible to do, to get an orbit like that, without interacting with something else, something that we don't know about. Had to pull Sedna onto the weird orbit that we had. I thought I knew the answer back when we found it in 2003. We wrote this very optimistic paper saying that this is a leftover from when there were many stars around close to us when the sun was born. Those stars have moved further away, and one of those stars got close enough to have pulled Sedna onto its orbit. It's actually kind of an amazing thing to think about when the sun was first born, that we were in a cluster of maybe 1,000 other stars, all closer than the closest star right now. If you could look up in that sky, which didn't exist because the Earth didn't exist, but if you could look up in that sky, you would have 1,000 things brighter than the brightest star in the sky now. I kind of wish we could go back and see it. And one of those maybe pulled off Sedna. So we started looking for more of them, and more of them. And one of my grad students, her entire PhD thesis was to find more of these objects to map out this part of the sky. And in her PhD thesis, she found precisely 0. A little too bad, but she has a nice job now, so it's good. Because for funny reasons that kind of will make sense if I remember to tell you, which I probably won't. But during that time, we found a couple of other things that were weird. Let me show you the set of objects that are weird. Here is, again, the sun is here. This is Neptune's orbit. This little white circle is Neptune orbit. And these objects are all on very distant orbits, 5,000 years, 10,000 years. One of them is Sedna. The sort of more purple one is Sedna. That's Sedna. Without knowing anything about them, you look at them and you will quickly notice one thing, which is that they're all kind of swept off to one side. They're all swept off in this direction. I will tell you, that is statistically improbable. They should be randomly distributed around the solar system. And what I'm not showing you is that if you tilted this on its side, you would see that each one of them is tilted by about 20 degrees in the same direction too. So they're all swept off to one side and askew in the same direction. And when we first noticed this, I walked down the hall to my colleague and friend Konstantin Batygin, and I was like, dude, what's going on here? This is weird. And he's like, yeah, but you know a really stupid explanation? I'm like, yeah, tell me a stupid explanation. He's like, there's another planet out there. And we both laughed, like that's dumb, because everybody knows that we knew all the planets. There are no new planets to be found out there. Only crazy people, those 35 previous crazy people, only crazy people say there are new planets out there. So we spent a year trying to figure out what could possibly do this. We thought maybe the Milky Way galaxy's gravity could do it. Maybe there's enough gravity for all the objects themselves. We could not figure it out. And so in a depressed fit of feeling like failures, we decided to show how well a planet could work. Oh, so embarrassing. So we did the calculations. This is good. I like to say we did the calculations. Konstantin does all the calculations in his head and on the board, and I just kind of watch and pretend like I understand what he's doing. But we did all the calculations and showed, like, you know what? This planet works really good. So we're like, oh, God, it might be a planet. Let's do some computer simulations. So I'm going to show you one of our early computer simulations just to show you what a planet does, because it's kind of cool. Here is Neptune's orbit is, again, that little circle. So we're looking at really far out. Each one of these bluish things is a very eccentric orbit of an object out there. So you're only seeing the orbits, you're not seeing the objects themselves. And the orbits are going to move around. And this pink thing that you'll see more of is a planet, a big, massive planet. So let's see what happens. You put it, in general, crossing the orbit of a big planet is bad. So let's see what happens. First thing that happens is a lot of things just disappear. They disappear very quickly because crossing the orbit is bad. But a lot of them don't. Things that are close enough in kind of just sit around and go in circles and nothing happens. But it's these distant ones are going away, and you'll notice that they kind of go away. Most of the ones over here go away because they're always very close to the planet. Over here, they're sticking around a little better, and over time, this entire simulation is 4.5 billion years. We're about 2.5 in. Over the past 4.5 billion years, this planet slowly carves out this region of space, leaving only these things left over here. As it goes, you'll see that those are the only ones left, which is exactly what we see. And if I show you again on the side, if you tilted the planet, you get the same tilt and all these things here. We're like, oh man, it works really well, this planet thing, but we all know it's stupid. So we're not gonna, no one wants to be the 36th and 37th astronomer standing up and saying, there's a planet, and having everybody say, oh my God, these guys. But it works really well, and the implication is that if you see a cluster of objects like this, that you have a planet that looks something like this. So we stared at these results and didn't quite know what to do, and we decided that what you really want to do is take the observations and then you want to make a new prediction. If there really is a planet out there, what else should we be seeing? And one of the very strong predictions was something about how these objects, over time, their orbits move and turn into some very peculiar orbits that we didn't think we had in the solar system. So I'm like, look, we're predicting something that we've never seen. We should be seeing it, this must be wrong. And then I realized that there was a database of things that had kind of been overlooked by me. I went and looked at this database, and all of these objects that we were predicting were just right there. It was exactly what we predicted, and we were sitting in my office when we saw this, and I think our jaws hit the floor, and we're like, oh, there really is a planet out there. And this is the moment when it went from a cute story that kind of explains things to, in my head, I now realize that we are looking at something that really is a massive planet out there. So there are a lot of other predictions that have been made. This was embarrassingly long ago now. This was in 2016, 18, a long time ago now. I confidently said we would find it within 2 years. I've said that every year for the past 8 years. I will say it later tonight. But I'm right this time, or unless I'm not. Konstantin always said it would take 10 years to find. So now his 10 years and my 2 years are about to collide, and we're going to be correct. We'll find out. So let me show you just some other really simple things that are predicted. The obvious prediction is that if this is real, we'll continue to find more of these and not too many over here. Our actual theory predicts there should be some over here, not zero, but we should find more. Originally, that was a hard prediction because these are very far away, hard to find. In the past decade, there have only been a few discoveries, but they have really borne out what we were thinking. Here are the discoveries that matter since then. One's the wrong direction, which I'm actually happy about because there needed to be at least one the wrong direction. But all these other ones are very hard to explain without the existence of a giant planet out at the edge of the solar system. And now, if you wanted to calculate statistics and say, what is the chance you would get this pattern in the sky just due to dumb luck, and it's not something else doing it, it's about 2.2%. So it's about one chance in 500. I'm willing to take that chance. I'm willing to take that chance and say, there's a planet out there, and now we need to go find it. Let me tell you what we know about the planet. So we know about it because of its gravitational influence. So the thing we know best is how massive it is. How big does it have to be to have that influence? The way we've learned it is with those sorts of computer simulations you just saw. We've done thousands of simulations where we crank the mass up, crank the mass down, move it a little closer, move it a little further, tilt it more, tilt it less, more eccentric, less eccentric, and we have come up with a range of parameters that works well. The most interesting one, I think, is the size. So when we first did this in some limited data, we said Planet 9 was 10 times the mass of the Earth, which is a really interesting range for a planet because it's midway between, sort of midway between Uranus, which is 14.5 times the mass of the Earth, and the Earth, which is precisely 1 times the mass of the Earth. And planet 9 is a weird mass that we had never seen in the solar system before. Since we've now done more simulations, I will update that to be something like 7. I like 7 a little better than 10. But it's the interesting thing about a 7 Earth mass planet is it's about the most common mass of a planet that we see in stars around the galaxy. And when I used to teach this class at Caltech on the formation of planetary systems and planets around other stars, I would always make the statement like, look, there are all these 5, 6, 7 Earth mass planets around other stars. Why didn't we get one? And we did. It's right there. We don't know what the planet is like. I have it here drawn looking kind of like Neptune. And the reason it's drawn looking kind of like Neptune is because the artist who was drawing it wanted to know what it looked like. I said, I don't know, make it look kind of like Neptune. And then I said, then put lightning on it because it'd be cool. So those are lightning flashes. But we don't know. It could be a 7 Earth mass big ball of ice, or it could be sort of a miniature version of Neptune. My guess is that it's more like a miniature version of Neptune. That kind of makes sense in the way that the solar system formed and in the way we think this got out there. But it might not be true. So let's go on the assumption that it's a big, giant Neptune-like object. How big is that? Well, let me go back to the solar system. There's our favorite solar system. I'm going to add in the objects that we found in the Kuiper Belt since then. There's Pluto. You can really see, if I didn't tell you that was Pluto, you might be hard-pressed to find which one it was. There's some of these other ones are ones that we found during that time when we discovered Sedna and all the other kind of big objects out there. There's Eris, which is more massive than Pluto. That was sort of the proximate cause of Pluto's demotion was the day we found Eris, something was going to have to happen. And what happened was Pluto died. Sorry, not sorry. But all the other Kuiper Belt objects. Now, add planet 9, and it is big. This is, if you were just going to, draw these 4 planets and say, what's the next one? That's about the size you would draw, just, looking at the patterns going on. It's out there. It is not a slightly larger than Pluto. Let's all argue if it's a planet or not. This is the 5th largest planet in our solar system, and it's just out there waiting to be found. So, how are we going to find it? Well, we have spent these last 8 years, always about to find it in the next 2 years, working hard on finding it. But we work hard in 2 ways. One is, rather than just jumping to the telescope and spending a lot of time in the telescope, the first thing we did was try to understand where it should be. So again, all these computer simulations that we talked about led to predictions of what kind of orbit it has in the sky. And I'm going to show you, this is an actual figure from one of my scientific papers, but I'll walk you through it. This is a map of where planet 9 should be and the probability of finding it in different places. Now remember, when Urbain Le Verrier predicted the existence of Neptune, he said, go look right there. And there it was. We can't do that. So we are terrible compared to Urbain Le Verrier, and I will never get a statue in Paris, which is really all I want. The reason we're terrible, though, is because he got to watch Uranus go around the sun 2 times, or had data from it, and could map out what was going on. We don't get to do that. So all we can tell is what the orbit is, not where it is in the orbit. But if we know the orbit, so this is a map of the sky. So just think about it like a globe, a map of the entire Earth, but now looking up instead of looking down. The equator goes across here. This dark line that you can barely see is the ecliptic, the line where all of the planets are. And this band is the Milky Way galaxy. And the colors show you the probability of finding planet 9. Red means most probable, light blue means least probable, this means no chance, man, don't look there. So the most probable location is up in here. So we spent a lot of time looking through this most probable location, but the problem is, it's a big area of sky, and the other problem is, it's not bright. So, because it's far away, this is the distance in astronomical units is 1 astronomical unit is the distance from the Earth to the Sun. Neptune is 30, which is really far away. This is 200, 400, 600, 1,000. This is really, really far away. And its most probable location is where it's most far away, 600, 700 AU. So it's really far out there. The bottom plot is how bright it is. This is in magnitudes, which is what astronomers use. Astronomers do it backwards. Larger numbers are fainter because astronomers are weird, but this is really faint. So as a way to calibrate yourself, if it were down here, you could see it in the backyard telescope. Sadly, it's not down there. There's like good telescopes you could see it from. If it's up here, there's not a lot, and if it's up here, there's only a few, and if it's up here, it's really, really hard. I think we're in this range here where it's tens of large telescopes are the only things that can do it. The problem with large telescopes is that there are other astronomers who want to use them. I don't see why they should be allowed, but they are allowed, and so I cannot be on the telescope every single night looking for a planet. So what I need, if you were to hand me $1 billion and say, go build a telescope to find this planet, I would say, here's what I need. I need a telescope it's a big telescope. It has to be one of these sort of tens of biggest telescopes in the world size telescope. But I want it to scan the sky night after night after night. And when it's done, start over again and start over again. Because the way you find it is just like we started out with William Herschel. You take a picture of the sky and you come back the next day or 3 days later or a week later and you see it move. And the only way we're ever going to get enough sky where we get to see it and come back and see it, because we have so much sky to look at, is if we have a dedicated telescope doing this night after night after night. And after you handed me $1 billion, I would hand it back to you and say, I don't need it, because this telescope was just built. Not to find Planet 9, but they built the best telescope that you could possibly build for finding Planet 9. Actually, if you gave me $1 billion, I might see if they could make it slightly bigger, but I'm not sure they could. So this is the Vera Rubin Observatory that you might have been hearing about in the news just in the last couple months. And it's really going to be fully operational. They say October 1st. I'm maybe holding out for January 1st. What it's going to do is scan the sky night after night after night. It takes about 3 days to do the whole sky. Then it's coming back and do it again. And then it's to come back and do it again. And I'm going to be looking for anything that is here one night, 3 nights later it's here, 3 nights later it's here, and then I can connect these dots to an orbit that is infinitely far away. Not infinitely far away, very far away. The data are, interestingly, totally public. It's a great telescope. They're just dumping the data to anyone who takes a look. So I will not be the only person looking. So it's entirely plausible that some like snot-nosed kid who's been wanting to do this all of her life figures out a clever way to do it, because these days it's not like being a telescope being an astronomer at a telescope. It's really about like figuring out how to do machine learning and big databases and all this stuff, which is what the kids these days do better than me. So I will not be surprised when some second-year PhD student calls me up and says, hi, I just found your planet. And that's fantastic, sort of. It'll be great. I think it'll be fantastic to find it that way. I'm going to try. You can't stop me. I'm going to try. Might not succeed. Now, where do I think it is? I showed you that most probable area. I love what the most probable area is just because it's one of my favorite spots on the sky. And if you wake up in the morning, has anybody been getting up super early and seeing Venus and Jupiter up in the morning, other than my wife, who's like, there are 2 bright things, Venus and Jupiter. It's like you don't even have to look. But they're beautiful in the morning if you're up early. But you can also, this is the time of year you can start to see everybody's favorite constellation. What's everybody's favorite constellation? Yeah, right? That's everybody's favorite. So here's Orion. Planet 9, the path of Planet 9 goes right through Orion and Taurus. Taurus the bull. Orion and Taurus are locked in this cosmic battle. In some of the Orion either has a bow and is shooting at the bull, or a shield and protecting himself, depending on what drawing you look at. The bull is charging, and Planet 9 is the peacemaker going right through the middle of them. I think it's actually, most likely spot is up in here. You can see there's more stars up in here. This is the Milky Way galaxy. It makes it harder. Having all those stars in the Milky Way galaxy is really going to make our job a lot harder to pull out that one star in the midst of this field. But you know, that's why it's fun. So, Vera Rubin Observatory, let's say it starts December 1st. I think we'll find it within 2 years. I really do, though. If it's going to be found by a telescope in the next decade, it's going to be Vera Rubin, it's going to be in 2 years. If Vera Rubin doesn't find it, it just means that it's further away and at that edge where we couldn't see it. And that's going to be hard. And we have some schemes, but they're going to be hard. And it's going to really require I think, a new generation of people to figure out how to do this next one. So I'm hopeful that very soon we're going to be there. So I want to leave enough time for questions for everybody. So I'm going to end with just where we started, which is my favorite poster on Planet 9. Many of you know where this came from, which is stolen blatantly from the Plan 9 from Outer Space movie. How many people have actually watched the entire movie? Wow, you guys have sad lives. So it's terrible. It's famous, as everybody will know. It's famous as having been voted the worst movie ever made. Literally true, right? So and it's, you know, if you try to watch it, you will understand why. So it's Ed Wood, who is a genius. It's got Vampira. It's the last appearance of Bela Lugosi, posthumous. They found footage of him and stuck it in after he was dead. It's actually got, weirdly enough, a young version of Konstantin right here in a spacesuit. I don't know why. But my favorite thing about this is it involves space zombies and weird stuff that I don't understand. But Ed Wood, I mean, crazy genius. But in this one scene, there's a scene where they're digging up the zombies in the graveyard. And if you zoom in on this poster from 1959, like Pluto had just been discovered 20 years earlier, but let's zoom in on that poster and see what's written there on that gravestone. You can see it right there? See a little writing there? There it is. It's Ed Wood, genius. Thank you.